In this video, we'll learn about the functional groups in organic chemistry. Before we start, I suggest you get a piece of paper or get some flashcards. You're going to have to memorize the functional groups. So flashcards is probably one of the best ways to do it. And this will be one of the only times I suggest flashcards. But get a piece of paper so you can at least write down the functional groups as we go through them in this video. So to define a functional group, it's a collection of atoms at a site that has a characteristic behavior in all molecules where they occur. So they'll act similar no matter what molecule you have. And functional groups tend to react in a typical way, but they're generally independent of the rest of the molecule. So it doesn't necessarily matter what I have around the molecule, just as long as I have that functional group. And so an example, if we had a double bond, so let's say we have our double bond, it doesn't matter if it's in a simple molecule like I've drawn here, or in a much more complex molecule. They're all going to react with bromine in the exact same way. So if I take my alkene and I react it with bromine, it'll give me a molecule with two bromines on it that end up in opposite directions. And so this wouldn't matter if it was a simple molecule or if it was a really complex molecule, I'll still get the same reaction with that double bond. And so now to start reviewing our functional groups, let's start with the simple ones. So we'll look at just functional groups containing carbon and also ones containing halogens. So our simplest functional group we can have is two carbons that are sp3 hybridized. That's also known as an alkane. If I take those two same carbons and now I make them sp2 hybridized, I give them a double bond, or they become alkenes. If I take those same two carbons, and now instead of a double bond, I make a triple bond, they now become sp hybridized, which gives us a new functional group of an alkyne. So here we have alkanes, alkenes, and alkynes. So we can take it a step further now and compare the pKs of these three functional groups. So remember, the pK of alkanes is approximately 50. pK of alkenes, or double bonds, approximately 43. pK of our alkyne, approximately 25. So you can see changing that hybridization, we lowered the pK. And so alkanes, not very reactive. They don't really do much. So the first one up here, these don't really do much. It's only once we get to that double bond, the alkenes, that we start getting more interesting chemistry. And even with the alkynes, we can get more chemistry with the alkynes. We also have a special functional group where if it's a six-membered ring with alternating double single bonds, all those carbons are sp2 hybridized. And this is known as an arene or an aromatic ring. And then finally, if I have a carbon that has some sort of halogen, the halogen could be a fluorine, chlorine, bromine, iodine. That's going to be known as an alkyl halide. And that'd be our functional group that contains a halogen. We also refer to as alkyl halides. Or sometimes you might alternatively see them known as haloalkenes or alkanes, sorry. So we have 4 functional groups that contain just carbons, and then we have our first functional group with carbon and halogen. So now let's look at functional groups that contain nitrogen and sulfur. First, let's start with that nitrogen. If it's attached to our carbon, it can make 2 more bonds. All of them are sp3 hybridized, and this is known as an amine. Now with our amines, we can get a little more specific with them, and we can have a primary, secondary, or tertiary amine. So primary amine, the R groups, they all equal a hydrogen. And a secondary amine, let's make some space over here. In a secondary amine, one R group equals a carbon, and the second R group equals a hydrogen. In a tertiary amine, both R groups equal carbons. So there's no hydrogens on a tertiary amine. Then after amine, we have a carbon and a nitrogen that have a double bond. So here they're sp2. And this is known as an imine. It's not a very common functional group, but we see it occasionally. And then finally, if you have a carbon that has a triple bond to that nitrogen, the sp, that's known as a nitrile. We also have a couple other types of nitrogen containing functional groups. One other one I want to bring your attention to is what's known as a nitro group. The nitro group is a nitrogen bonded to 2 other oxygens. And then there is one other group that contains nitrogen and amide that we'll see a little bit later. And I'll show you guys the amide again a little bit later. An amide is a carbon double bond to an oxygen, and that carbon's also bonded to a nitrogen. So, lots of nitrogen ones. Let's look at a couple sulfur ones. So the first sulfur one is if we have our carbon, make some space. We have our carbon bonded to an SH. That's known as a thiol. You can also have a sulfur in between 2 other carbons. That's known as a sulfide. Or you can put 2 sulfurs in between. Having 2 sulfurs there gives us a disulfide. We may also occasionally see something that's called a sulfoxide. So that's where we have our sulfur double bonded to an oxygen. Not too bad so far. So as I said, this is best to learn through kind of flashcards and have them memorized. So now let's get to a bigger group where it contains oxygens. So first we'll do where the carbon is an sp3 carbon, and then we'll look where it's an sp2 carbon. You'll understand why I'm making the distinction in a second. So here's our sp3 carbons. So they're all single bonds to oxygen. So the first one, we have a carbon with an OH attached to it. That's known as an alcohol. We can also have our oxygen attached to two other carbons, and that's known as an ether. Or a third type, if we have that oxygen in a three-membered ring, that's known as an epoxide. So not too bad. We got three different types. Now we're going to look at our biggest group. They contain oxygens in what we call a carbonyl. So this is where our carbons are sp2 hybridized. And so all of our functional groups that contain carbonyls have a carbon that's double bonded to an oxygen. There's something on one side. And then this third side is what changes. And every time we change something on this third side, we change the functional group and we change the name. So a lot of them are going to look really similar. This is where you just got to practice and repetition, seeing them over and over is really the only way you're going to learn to distinguish them. So our first one, if we have a hydrogen, it's known as an aldehyde. If it's another carbon, it's a ketone. If it's an OH, it's a carboxylic acid. Something similar to acetic acid. If it's an OR, so kind of looks like a little ether there, that's known as an ester. So don't confuse ester with ether. Ester includes a carbonyl. Ether, no carbonyl. So ester, carbonyl. And then we have our group with our nitrogen. Remember we saw that before, that's an amide. If we put a halogen there, I'll do chlorine. Put a chlorine there, that's known as an acid chloride. If it's just a generic halogen, we usually call those acetyl halides. We also have another functional group that contains an oxygen in between two carbonyls. This is known as an acid anhydride. You with me so far? See, I told you guys there'd be a lot of carbonyls. So these are some of our basic functional groups that I think you should learn and that you should know. So again, as I recommend, go through the video, write down all these functional groups on a flashcard, put the name on one side, and then draw the functional group on the other side. Keep going through the flashcards till you know all of your functional groups. And you're able to identify a functional group if I give you a large complex molecule.